Good afternoon from me. This talk will be completely slideless. So everything I will be talking about will be just a code and how to do this and that. And luckily, we will manage to really do some stuff and let it running. So what it will be all about. I'm really into the IoT, especially SoC like ESP or Arduino or stuff like that. Means chips which are not that much powerful from the computing point of view, computing power point of view, and even not having that much memory. So MicroPython could be perfect fit for those, let's say, microcontrollers. But what else? Every, let's say, mature IoT solution should be connected to internet somehow. And nowadays, having all, let's say, cloud platforms supporting only secure connection or MQTT or protocols like that. So using those protocols, it's not easily achievable with the microcontrollers, as I said, because some secure layer is, let's say, demanding from the computation point of view, computation power point of view, and all the libraries are really huge. Speaking about memory in kilobytes or megabyte maximum. So what I will be showing to you today is how to connect microcontrollers running some MicroPython code to public cloud, even obeying or, let's say, following the rules, like it has to be somehow secure as much as possible. For demonstration purposes, and maybe let me start with a GitHub, because everything I will be talking about is publicly available on my GitHub. So github/postpanet/PyIoT. So all the code for and even the cookbook, how to set up environment and how to install MicroPython on ESP8266 is already there. So you can follow together with me. I will take few assumptions, like you already know how to upload or flash MicroPython to your microcontroller. And let me do yourself familiar with the tooling I will be using. So for debugging, I will be using ESPlore. It's a tool developed in Russia by our Russian colleagues, and it's really powerful. And nowadays it supports even Python. So it's great tool which can be used to debug the stuff, and it's especially for ESP8266 chips. Even if you like to use some other platform like Lua or something else, you still can use this tool. I'm just thinking. Okay, as I said before, I will skip how to set up the Python or MicroPython into the chip. If we will have some time, I can explaining even that. So I was talking about there's no option how SSL can be used. Okay, there are some options how you can achieve, do some calculation to compute SSL even on ESP. But as I said before, it's much more complicated, and having all necessary libraries inside a chip, not giving you that much space to do your stuff. So I was thinking like, okay, we can use something HTML based because it's really simple, and working with sockets on MicroPython, it's really easy, as you will see later. So how to do some secure connection to cloud, not having secure socket layer. I was thinking like, okay, how about one-time passwords? Okay, it can be readable during some man-in-the-middle observation or attack, but still, if somebody captured only that one-time password, it's kind of useless. He still can overcome your communication somehow, but it means he has to manipulate the communication, and it's not that easy. And having that assumption that we cannot afford some SSL, I think it's quite enough. So what options do we have? In my case, I will be using Microsoft Cloud, especially Azure Functions, which is really easy to use, and you can do whatever you need with that. So my setup is like, okay, I have some IoT device. It can be some measuring device, like measuring temperature, whatever, and sending those data to cloud to do some post-processing and do some controlling based on the data we've received. So let me start with a Python code. As you can see, and I'm giving you also my credentials to cloud and credentials to be able to connect to my mobile phone, where I have an access point for ESP. So please do not do any kind of DDoS or whatever. Otherwise, I cannot complete my demo. So as I said before, I will be using ESP8266, which is a chip this size. So the chip is like half size of the board. But even that, it has also Wi-Fi part on it, so you can connect to the network using the Wi-Fi, so no wiring requires. So connecting to Wi-Fi is really simple. Those 4 lines are enough. Actually, those 3 lines are enough. The last one is just to double check that the connection was successful. And everything else is just about some preparation, some payload, which will be then sent to cloud. So let me try to let it running. Firstly, I have to double check if my access point is still up and running. Yes. So let me include all the libraries. Let me set up all the environment variables we're gonna need. No error so far, perfect. And then let me connect to the Wi-Fi network. Wow. Okay, so what's wrong? SSID. It should be all okay. So let's run it line by line. Why not? SSID is... Oh. It's a beauty of live demo. So now, yeah, perfect. So we are connected and we received some network configuration. So we should be able to connect to the internet. Speaking about internet, we have to have some remote function which can be called from the ESP in a really simple way. So for that purpose, I do have my Azure function already prepared, I hope. Let me refresh just to be sure. So what Azure function really is in the meantime? Azure function is kind of, in this case, HTTP or HTTPS, in this case HTTP endpoint, where you can run your own code. At the moment, it could be C# or JavaScript, and JavaScript is really, let's say, common, so you can use the JavaScript. In my case, I will be using C# because it's much closer to my heart, let's say. So this is the code, and let's take it really just as a sample. It's not that important what is running on the Azure part. I will take it just a reference and just for demo purposes. So as you can see, it's kind of, maybe you can't read the C#, so let me explain it a bit. So it's kind of handler running in some, let's say, abstract web server, and every request which goes to the specific address, which you can define, ended up in here. And in here, you can do whatever you need. So in my case, I will be parsing some values from the requests. So I will be parsing out the value which can be sent as a part of a query string or inside a request body. And the second, it's a name, so value and a name. How the requests can look like. So the resolution is really like, okay. Can I move it to the side? I can't, unfortunately. Doesn't matter. So I can take the function URL and call it directly like this. So this is my endpoint, and I'm getting the error like, okay, the name and value has to be passed to the function. So let me add those two. Okay, so name will be ESP8266 and value will be 1234. And if I call it like that, nobody, just a pure request. So I've received a message like, hi, ESP, I receive a value, blah, blah, blah. So this is really just a simple web call which can handle your payload, whatever will be inside. At top of it, I'm sending those values to something called IoT Hub. Not important what the IoT Hub is at the moment. If we will have some time, I will explain it in more details. But it's a part where you can do some processing of your data and then do some visualization or commanding back to the device or whatever. So, and yeah, I was talking about some one-time password. So there is an option using the Azure function to define a list of one-time password out of the box and then store those passwords somewhere on the device. But still, you have to consider like, okay, if somebody will have some physical access to the device, he can read out the data from the memory, and you are screwed. But still, you can have some functionality like, okay, the device will be boxed. And if somebody will try to hijack or open the box, you can send some alert like, okay, this device was compromised, so please do not accept any value from this particular device. So go back to the Python code. So as you can see, we have an address, we have a connection to the internet. So what we have to do to be able to send those values to Azure function is to construct the request. As I said before, the payload can be transferred as a part of query string, which is really simple, or as a request body. In my case, I will be using the query string. So I do have a function name, I do have a function host, and all the necessary values from which from those I can construct the query. So let's get the host name. Okay, why is that? Okay. Now it should be working, I hope. Perfect. Standard HTTP port. So this is what we have. Okay. PyIoT Azure websites. Let me just double check. PyIoT Azure website.net. And the key start with CR681. CR681. Let's get the IP address. So this is our IP address. Perfect. And let's try to make a call. By doing that, wow, okay. What the fuck? Perfect. So this is URL, and let me send it to the internet. Oh, like that. Perfectly. We successfully sent 130 bytes to the internet, which was just a header, nothing else. 10 minutes left. Perfect. I think it's more than enough. So yeah, I didn't implement it functionality like rotating all those one-time password, but I think you can imagine there will be some array of all the password, and what you need to do is change that password. In my case, I name it like function key, and all those key can be used just once. So even if somebody take over that one key you have used for a call, it's like over, and nobody can hijack your backend system. So I can let this code running and focus more on. Perfect. Now we are sending the values to the internet in an infinite loop. And we can take a look more on the internet part of the story. So the magic behind this code is like I'm receiving all the data from my IoT device or even devices. By the way, the function app can automatically scale up or scale down based on number of requests, so you don't need to be worried about the throughput or anything else from the performance point of view. And then I'm sending those data to something called IoT Hub. IoT Hub is a special functionality where you can store your data and can be used as a data pump between whatever is on the internet and some advanced analytic. From the advanced analytics, I'd like just pointed out something called, wow, I forgot the name. Streaming analytics and Power BI for the visualization. But because this speech is purely about IoT and Python related code, I will not give any even overview of those services. But in case you are interested about how to process the data in really huge amount, feel free to reach me after the session or through the email. And as I said before, all the code and all the tooling which you gonna need to reproduce the demo, you can find on the GitHub together with let's say cookbook how to do that. I'm more than welcome, or I'd like to encourage you to comment on those code, and because the idea behind this repo is to create some like solid database about how to start IoT using the Python. There are tons of snippets all over the internet, but most of them are old. Let's say, let's put it in this way, and not working anymore. So I'd like to keep this one as actual as possible to have something like reference book for you. So we still do have like 5 minutes. So questions. If not, I can continue with the services I was talking about on the Azure part. But firstly, questions. Okay. We have a lot of questions. So applause first. Thank you.
Okay, first one is the shortest one. Semicolons?
Why not? I get used to semicolons because of C, C++, and C#, so that's why.
Okay, second one. Do you think that security is still not priority number 1 in IoT industry?
Tough one. I think it is. Or it should be. It's not. We are not there yet, but it should be. So every time you will be doing anything for IoT, please consider the security in, let's say, top 3 at least. So if you take protocols like, okay, I will not mention any specific name, but there are some protocols which are unsecure by default, and they are widely used in home automation, for instance. So you can easily hack those devices, and through those devices you can get the user data which are securely stored at her home. So please consider security in any IoT scenarios, even if the IoT is not connected to the internet.
Okay, next one. Why using Azure when it doesn't support Python and you must write server-side in C#?
It's not fully true. you can use Python not in Azure Functions, but in the other parts of Azure. And why Azure? It's basically because I'm a Microsoft guy. That's why.
Okay. Is there a way how to achieve that without Azure?
Sure, you can use any public cloud provider because all of them having something similar to Azure Functions.
Are the user tools available for Linux?
All of them. All of them.
Great. Do you have idea how to prevent hackers from using our IoT devices for DDoS attacks like recently used botnet attacks?
Back to the first question. It's like take into the consideration that your device or environments will be exposed to the internet. So having like just hard-coded passwords, etc., it's not a good approach how to, let's say, overcome all those threats. So if you think first and then do the coding, I'm pretty sure that you are smart enough to avoid those situations.
Okay, what about IoT gateway with SSL? Is that the way to go?
Sure it is, but still, if you wanna, let's say, overcome the scenario like the dumb IoT device communicating directly through the internet, there will be a last mile which you have to, let's say, secure somehow. Okay, the setup could be like there's a field gateway which is able to do any SSL or whatever, and all the field devices are connected to that one device, acting really as a gateway or concentrator. So local network can be unsecure if it's wired. In this case, we do have just Wi-Fi. Of course, we can do some SPI, R2C or whatever, but I'm talking about the IP stack. So even if everything will be transferred just locally, but through the wireless technology, you have to think how to protect your devices. So yeah, the SSL gateway can help you to make the connection more secure, but still the last mile is the channel you have to secure enough.
Okay, which ESP32 board do you recommend to go for, or should I wait a bit more?
There are some new ESP boards having even some STM chips on it, but I'm using ESP8266. That one has like 16 different GPIOs, as far as I remember, maybe a bit less, but any of those are good enough. So every time you start any IoT project, write down all your requirements, and based on those requirements, you can find the board which is, let's say, perfect for your project. In most cases, I can see a situation like, okay, I will use Raspberry or I will use Dragon board or whatever. But why? Power consumption so high, so you cannot let it running on a batteries. Operating system bringing some new, let's say, challenges, also giving you some advantages over the microcontrollers. But the power consumption should be number one, because if you are playing with IoT as a home automation, I'm pretty sure you don't want to be going around and replacing batteries every single week or month or whatever. So try to find device which is powerful enough to do your business, but still as small as possible.
And the last one, why didn't you create API backend on Python, says with Bottle framework?
I don't get it, Bottle framework. So I was talking about the situation that the Azure function is not supporting Python at the moment. You can use any I forgot the name. Web API. Web app, not web API. There's a block called Web App which supports Python, so you can run Python directly on it, but it's much more complicated and you have to write more code that just those, I don't know, 12, 16 lines I wrote for the Azure functions. And as I said, Azure function can be programmed using the JavaScript, and the JavaScript is, let's say, the standard in IT world, so you can use even the JavaScript. Or Python, but using not Azure functions, but web apps.
Okay, thank you very much.
Thank you.